So this first lesson, systems of equations. Today you guys are going to be able to determine the best method to solve a system of equations and then of course solve the system. There are 3 ways to solve a system: substitution, elimination, and graphing. And we're going to talk about all 3. Okay? Everyone has time to go, yes? Okay. So, the first one is substitution. The best way to, I feel that I'm going to be able to portray the steps when it comes to doing something by substitution is through an example. So, here's an example. We have a system 2x plus 4y equals 18, and then we have y equals 3x minus 20. Go ahead and get this one down in the substitution section. So here we have an example of a system. We have 2 variables, 2 equations. Now, a problem like this would be best to solve using substitution. Reason why? Can anybody guess? Yes. It already has what y equals. It already tells you what one of your variables equals. And think about substitution means you're going to basically be substituting in something for something else. Okay? So since this one's already solved for y, pretty much all we have to do is take that 3x minus 20 in that second equation. So you took that 3x minus 20 and you plugged it in, right? You plugged it in for y. So then that gave you 2x plus 4 parentheses 3x minus 20 equals 18. Yes? What did I have to do with that for? Distribute. So then that gave me 2x plus what? Say it again.
12x.
Keep going.
Minus 80.
Minus 80. Equals 18. Very good. After this, we have to do what?
You subtract.
Combine them, add them together. So 2x and 12x make what? 14x minus 80 equals 18. Keep going.
You can barely hear me.
Actually, well, you're right in front.
My voice really annoys me right now. What's wrong?
Too often.
It's your.
What do I do from here? Yes. Add 80 to both sides. And what is 18 plus 80, Sonny? 98. And then the final step is divide. Yes. And 98 divided by 14. Did it come out to a whole number?
Yes.
Yes. It, what? 7. So we have x equals 7. Okay? So we found what one of our variables is. But there are 2 variables, correct?
Yes.
Which means we have to figure out y. And since y was already equal to 3x minus 20 from the beginning, all we have to do now is substitute 7 back in for x. Okay? So that's going to be y equals 3 times 7 minus 20. What's 7 times 3? 21. So y equals 1. So I have x equals 7, y equals 1. When it comes to a solution in a system of equations, it's always written as a point. Always written as a point. X is 7, y is 1, so the answer is 7, 1. All solutions with systems are written as a point. Questions? It's okay to ask questions. So I want to make sure everyone has substitution down. Okay? I want to make sure everyone has substitution down. This handout is on page 7, right? So I want you to go ahead and flip to page 8 on your lined pieces of paper, and I'm going to give you another system. Okay? And I want you guys to do this one on page 7. So this will be like our more examples page. All right? Here's one Write down the full system, and then I want you guys to solve it. Saw some good things. I saw that you all took that x minus 13 and you plugged it in for y. Okay? So that was something that was good. But then I saw a lot of you guys forgot that when you distribute this over, it was a negative 5, which is going to affect this number here when you multiply by this minus 13. A negative and a negative make a what? A positive. So when you distribute that negative 5 over, it'll be a negative 5x and then a positive 65. Okay? You got to be careful about your signs. Now, once you solved it down, like kind of once you got to the end, if you had didn't carry over that negative, you probably would have ended up with a decimal. Not saying that, I mean, decimals could happen. Okay? There's nothing wrong with decimals. They're just fractions. Okay? But definitely go back and double check just to make sure. Okay? Combine like terms. Negative 4x minus 5x is what? I heard it faintly from one person. Negative 9x. Okay? Plus 65 equals 2. From here, what do I need to do, Brianna? Uh-huh. Positive or negative? Careful. So that it's going to be a negative since the large number was negative. Okay? So good. Bring it down and then what? Very good. Positive 7 for x. Yes? Okay. Once I find x, I plug that back in for my equation for y. And what's 7 minus 13? Say again? Negative 6. So my final answer is written as a point. 7, negative 6. Make sure it's written as a point. Make sure it's written as a point. Always write your solutions as a point, especially if you get a value for x and a value for y. Okay? We're going to do another one. We're going to do another one. Let's do this one. Okay, so for this one, you guys remember about the negative? Okay, let's see. Did you take this x plus 12 and plug it in for y? Okay. And when you distribute it, did you get that? Okay. When we combine like terms, negative 2x and negative 5x. Negative 7x. Good stuff. After this, it's just a two-step equation. Add 60. Positive or negative? Positive 56. Divide by a negative 7. X is what? Negative 8. Yes? Awesome. Then we go back and we plug that in for y. So you have negative 8 plus 12, which is a positive 4. So my final answer is negative 8, positive 4. Everyone can read my handwriting. Awesome. One more. It's going to be a tad bit different. All right? We look at this when we have x minus 2y equals 4, and then 3x plus 8y equals negative 16. This one's different from the other ones. Why? Doesn't have a y equals or even a x equals, right? You have to solve for one of the equations to get one of the variables by itself. Okay? So you have to decide, am I going to take the equation at the top or the equation at the bottom and solve for one of those variables? Which one do you think would be the easiest? The one at the what? Top. Because, and solve for what variable? For x. Because there's no coefficient in front of the x. So it'll be pretty simple to solve for x, get x by itself, and then you'll have what you had in the other problems, right? How would I take this equation, x minus 2y equals 4, and solve for x? What would I need to do? Anyone?
The top one. So we're trying to solve for x. Okay.
Add 2y to 4. So if I add 2y to both sides, can I add 2y and 4 and get 6y? Mm-mm. It just becomes 2y plus 4. Now that I have x equals 2y plus 4, it now looks like those problems that you did before, right? You solve for one variable. Now we're going to take that 2y plus 4 and plug it in for x in that second equation. Does everybody see that? Okay. Go from here. Let's see. Okay? So from here, we were able to take the first equation, solve for one variable, so that way we could substitute it in. So when we substitute it in, we're substituting into the second equation. And then we're solving from here. Okay? We're going to distribute the 3 to get 6y plus 12 plus 8y equals negative 16. Combine like terms. 14y plus 12 equals negative 16. Subtract 12 to get a negative 28. Divide by 14. And y should be a negative 2. You guys get negative 2 for y?
For x, you write down the little problem up there, the 2y plus 4.
We're talking about back up here where we solve for x?
Oh
Or
wait,
back
we
to
can
the
just solve for it.
Mm-hmm.
Yeah.
Since we already solved for x back here, we can just plug it back into that. Okay? You can plug it back into the original first equation, but you'll end up essentially doing this. Okay? So, x equals 2 times negative 2 plus 4. 2 times negative 2 is a little louder.
Negative 4.
And negative 4 plus a 4 is a 0. So your final answer is 0, negative 2. Questions?
I never really confused myself. I went through your studies and my paper wrong.
Mm-hmm. And that will do it.
I almost had 8, -2, but then I saw it was a -12 up there. I changed my answer.
Good. Good way to recognize it, though. Good way to recognize it. This last one, I want you to do it on your desk, okay? That's why I went around and gave everybody a marker and a felt, okay? So get you some space on your desk, and I want you to do this one on your desk.
Mine's bad, but I can't read that. Alright, I've never had a special pen.
Michaela, how did you start? Mm-hmm. Very good. Okay, solve for one variable. Did you guys get that? Okay. Savannah, what did you do from here?
I typed it into the 3x plus 6y.
Okay. So you plugged it in. And then what did you get after you plugged it in?
Negative 3x minus 42 minus 30x equals 24.
Okay. Keep going.
And then I combined the x's, so I had negative 33x and then minus 42 equals 24.
Mm-hmm.
I added the 42 to the 24.
Mm-hmm.
And then I ended up with negative
X was negative 2. Anybody not follow with the process that she did? So everyone got negative 2? Okay. So then, Tanaris, what'd you do to find the other variable?
Plug it in.
Sorry, TJ. Okay.
Plug it in the first.
To the first one? Okay.
5 times negative 2.
Mm-hmm. And then? Negative 10 minus 7?
Negative 10 minus 7.
10 minus negative 7. Okay. Or 10 minus 7. So then what you get for y? 3. And did everyone write their answer as a point? Make sure you write your answer as a point every time. And that's substitution. That's one of the ways. Okay? That is one of the ways. Go ahead and clear your desk. We're going to talk about elimination next. Yes. Elimination is another way to solve a system of equations. Okay? Personally, I prefer elimination over substitution any day. Okay? I guess it's just the satisfaction of being able to just cancel out things and make it a little bit small, more condensed. Okay? But the goal of elimination is you want to eliminate one of your variables. If we look at this example here that I want you to add to your ivory colored sheet, we have 2x plus 10y equals 4, and then negative 2x minus 10y equals a negative 4. Okay? Your goal is to eliminate one of the variables. In order to eliminate, one needs to be a positive, one needs to be a negative, and they both need to have the same, essentially, coefficient. So in this particular problem, I have a positive 2x and a negative 2x that are going to eliminate. Okay? So I'm just going to go ahead and just get rid of it. Because they do. They eliminate. Cancel each other out. But then when I look at my y's, 10y minus 10y is what? It cancels out, right? Now when things cancel out, does that leave me with a 1 or does that leave me with a 0?
With the 1.
0.
Actually leaves me with a 0. Because if I do 2x minus 2x, that's 0, right?
Okay.
So I have a 0 essentially on the left side of the equal sign. What's 4 minus 4? 0. It's 0. This can happen. Okay, this can happen. Where all your variables cancel out and all your constants cancel out. When this happens, this basically means that all solutions, all combinations of x and y are going to work for this particular system. So your answer is going to be all real numbers. Or you can say solutions. So whenever all the variables cancel out and all of your constants cancel out and you have 0 equals 0, it's all real solutions. Okay?
So anything would work to solve that.
Anything. So if you made x1 and y3, you plugged it in, you're going to end up getting a true statement. Like, it's going to work out. All right? We're going to do some other examples. We'll do probably the first one together just to make sure everyone's good, and then I'm going to give you guys something to do on your own. Okay? So flip over to your more examples page. If you're like, well, I'm already at the bottom of that, that's fine. Go to the next one. It's not like we're doing a table of contents or anything, so if you need more space, use more space. Okay? Start with this one. So in your more examples, we got negative x minus y equals 17, and negative x plus y equals 3. Okay? So, yep, we sure can. Off gate. We have a negative y and a positive y, so the easiest variable to eliminate in this case would be y. They cancel out. Now let's go straight down. What's negative x minus x? It's going to be a negative 2x. Those aren't going to cancel out. It's basically a negative 1 minus 1. Negative 2x. What's 17 plus 3?
20.
20. And we are adding here. Okay, we are adding. This is a little one-step problem. How do I solve this?
Divide.
By?
By -2.
And what's 20 divided by negative 2? Negative 10. And we already have the solution for x. Okay? Now to find y, we just plug it back into one of the original equations, one of the printed equations. Doesn't matter. You're going to get the same answer for y, whether you plug it into the first one or the second one. Okay? So I'm just going to go ahead and take the top one of negative x minus y equals 17. I'm going to go ahead and plug in negative 10 for x. I'm going to solve for y. A negative and a negative make a what? A positive. So I have a positive 10 minus y equals 17. Subtract 10. Ran out of space. What's 17 minus 10? 7. Am I done? Got to divide by negative 1 to make it positive. What's 7 divided by negative 1? Negative 7. So my solution is negative 10, negative 7, and we are done. Said I like elimination because I get to, strike it out. Get rid of it. Bye-bye. It's gone. Okay? Questions? You guys remember this from a long time ago? Kind of. Slowly starting to come back. You skipped a lot. Look at this one. Look at this one.
That's very kind of you.
Not like that. X plus 2y equals negative 2. Negative 2x plus 2y equals negative 8. Just how it's written. Can I eliminate anything?
No.
No, I can't. There's no positive and negative and the same coefficient on either of my variables. But I could make it so that I could eliminate something. And to be honest, it doesn't matter which variable you eliminate. If you're like, I'm always going to eliminate x. It doesn't matter what numbers they are. I'm going to eliminate x. That's totally fine. However, it might be easier to eliminate y. Either way, we're still going to end up with the same answer as long as you do the math right, okay? But looking at this, what do you think will be easier to eliminate? Oh, so x? Okay, cool. So we're going with x. All right. So I would have said y, but it doesn't matter. We're going to get the same answer anyway. If I eliminate x, I have a 1x and a negative 2x. It has to be the same coefficient, and one of them has to be positive, one has to be negative. How can I make it so that my x's are going to eliminate? Multiply the top by 2, and we're multiplying everything by 2. That's the x, that's the 2y, that's the negative 2. Every single thing. Huh? So if I multiply by 2, that's going to give me a 2x plus 4y equals a negative 4. Do I need to do anything to the second equation? No. Sometimes I will have to multiply both equations by something, but it's not for this case. Do my x's cancel out now? Yes. So when I get rid of them, I have 4y plus 2y. Anyone? 6y? Negative 4 minus 8. Negative 12. Careful. Negative.
Teachers, please pardon this interruption. We are still missing quite a few papers of...
What's y? It's going to be negative 2 because I divide by 6. And it's a negative 12 divided by a positive 6, so that's a negative 2. All right? I have to find x, so that means I got to plug it back into what? The original. Doesn't matter which one. Okay?
Preferably the top one.
The top will probably be a little easier. That's for sure. So, going to plug in -2 for y. Going to multiply. That's going to give me a -4. And then I'm going to add 4. So x equals 2. All solutions are written as a point. I'm just going to. All right, you're going to do this one. Let's talk about this. What variable did you eliminate? Y would have been the easier one. Okay? You could have eliminated x, but you would have had to multiply both equations by something. Okay? But if we eliminate y, we can just multiply which equation by what number? The top equation by 3. Top number by 3, or top equation by 3. To get rid of the y. So that became a -6x minus 12y equals 66. Do nothing to the second equation, and my y's will cancel out. -6x plus 3x is what?
Oh, sorry. Oh.
-3x plus 66 plus 15. This is what you guys got?
No, it's
No,
-3x.
Oh, it's a negative. Oh, thank you.
Oh, okay. So I did.
Thank you for correcting me. I do make mistakes. It's right now?
Yeah.
Okay, cool. What's -6x minus 3x? -9x. And 66 plus 15? 81. Divide both sides by -9 and x equals -9. Plug it back in to my original. Doesn't matter which one. I'm always prone to the top one. That's just me though. You can plug into the bottom one. Do the same thing. -2 times -9. 18. Subtract 18. Divide by -4. Y equals -1. Did you write as a point? Good. Let's do this one. Okay? Let's do this one.
Are we not going to graph?
We will, but we're not going to do any examples. But we'll talk about it. This one, before I let you go, you got -3x minus 7y equals 10. -5x minus 5y equals 10. What do you think you're going to have to do here? Multiply the top and the bottom. Because this 3 doesn't go into 5, 5 doesn't go into 3, 7 doesn't go into 5, and 5 doesn't go into 7. So you're going to have to multiply both equations by a number. Okay? Now it's going to be up to you whether or not you want to eliminate x or you want to eliminate y first. You'll still end up with the same answer. Okay?
Could you not somehow make one of the 10s negative?
It would have to be one with a variable. That's a good question. It would have to be one of the ones with a variable. Okay? You want me to start you off, or you guys think you got it? Want to try it? Okay, I like that. Yes. And I'm always here for help if you need me. My hint to you guys is that when you have to multiply both equations by something, one, make the decision. Is it going to be x that's going to go, or is it going to be y that's going to go? And then figure out what number do both of those numbers, whatever variable you're going to eliminate, go into. So if you decide to eliminate x, what do 3 and 5 go into evenly? And then whatever that number is, you multiply by the number to get what they have in common. If you decide to eliminate your y's, what do 7 and 5 both go into? And then 7 times what number gives you that number? 5 times what number gives you that number? It's my hint. So, remember, when you have to eliminate and you have to do something to both equations to eliminate, you have to think, okay, what number do they both go into? Raise your hand if you eliminated y. Okay, looks like everybody eliminated x, okay? So that meant that I had to multiply the top equation by what to eliminate x?
5, -5. I did 5.
You could do positive 5 or you could do negative 5 as long as the bottom one, okay? So, one of them would have to be a negative, the other one would have to be a positive. Doesn't matter. I'm going to make the top one a negative just all right? So when I multiply, negative 5 times negative 3 is a positive 15. Negative 5 and a negative 7 is a positive 35. And negative 5 times 10 is a negative 50. Okay? 3 times negative 5, negative 15. 3 times negative 5, and 3 times 10, 30. Okay? Now, if you made the 3 a negative and the 5 a positive, that's fine. When we solve this out, our y should still be the same. Okay? So, positive 15x minus 15x cancel out. What's 35 minus 15?
20.
So I have 20y equals negative 50 plus 30, negative 20. Divide by 20, and y is what? Negative 1. Okay? Watch those signs. Watch those negatives. Watch those positives. Changes the whole problem. I'm going to go back in and plug this into one of the originals. Like I said, I don't know why. I'm just geared to that top one. Negative 7 times negative 1 is a positive 7. I'm going to subtract 7 from both sides. Negative 3x equals a positive 3. Did you guys get that? So that way x was a negative 1. No?
I got positive 1.
Yeah.
I got negative
Yeah,
1.
and
It's a
x
negative
would be
3.
positive 1 and y would be the negative 1.
I got negative
Hey.
3.
Yeah.
Wait.
Yeah. X is positive.
Okay.
I got negative.
Should be a negative. If I plug in negative 1 with that negative 7, that makes about a positive 7. Back here, the original problem was a positive 10 and a negative 3x. Subtract 7 from both sides to get a positive 3. Bring down the negative 3x, divide by negative 3. Should be a negative 1, negative 1. If you didn't get that, do you see your error?
Yeah. Stupid
Right.
negative sign again.
Do you guys see the difference from when to use substitution versus elimination? Okay. Now, realize if the equations are solved for one of the variables, substitution might be the easiest route. Okay. Elimination, if they're lined up like how these last couple of problems have been. Okay. But you need to be able to recognize that if I give you a sheet of systems, which one is going to be easier to solve? Which method is going to be easier? We'll talk about graphing on Friday, but we really don't teach you how to solve by graphing, because you literally are graphing these linear equations, okay? And so we don't do that, but I do want to go over it for SAT and ACT purposes, okay? But we will talk about that on Friday.